Good morning, Munanda. Offline Tamil handwritten character recognition challenges and analysis. My name is Antony research scholar in Anna University. Thanks to Dr. Abirami ma'am for the wonderful support. What is OCR? OCR is a technology used for converting the printed and handwritten document into machine understandable code. This is a process used for converting the same. So we're scanning the printed and handwritten document that will give in the image. So you are applying the OCR technology on the image to get the Unicode. The Tamil OCR. Tamil OCR categorized into two, online OCR and offline OCR. So taking out the character, that is Unicode character from the pen tip movement is online OCR. Offline OCR is scanning the image, handwritten and printed document image. OCR technology is applied on the image to taking out the taking out the Unicode characters. The general difficulties found among the Tamil characters, there is similar shape introduced by writers. That is, V look like Lee, T look like B. Unnecessary curves, unnecessary loops, middle of La. La look like Na. Similar in shape, O look like O. That is, a small curve variation create a similar shape. Minor variation among A and a small variation change the character shape. A looks like A. Shape variation among E. Angle variation leads to shape variation. D look like B. D look like B. Character discontinuity. It is character discontinuity in the characters Lu and Ni. Character structure discontinuity. There is structure connectivity. There is overloop. Unwanted loop on Na, Li, D and Ri. Unknown shape characters is Ri, He and He, but is look like unknown shape. Unnecessary loops is created by writers. Similar shape, A look like A, is Nu look like Na, Ki look like E, U look like V. That is double letters Au and U. Writing issues Ta and Lu is created by the senior citizens. The general reasons for these are the issues: handwritten characters of senior citizen and old Tamil poets, character mistakes when people form a sentence, writing pressure and sliding characters, handwriting of language learners and kids, individual style of writing, speed of writing, size of letters, overloop of letters, different size, thickness and format and dimension. These are the general difficulties which is taken from the 100 characters samples which is collected from HP dataset. Here 30% of characters are got with good for recognition. We can recognize easily. We can simply apply any kind of algorithm for recognize the same. And similar in shape introduced by writers, that is 5.4% issue. There is a 5.4% issues are found that is similar in shape introduced by writers. As shape variations, that is 22% of shape varied characters are available among 100. Here 64%, that is with the shape variation, and other variation, other issues also available with the same variation, other variation also available here. Okay, 64% characters are with other variation and same variation. 9.7% characters with location variation, 28% of characters found with location variation and other issues, and 2% of characters with structured discontinuity, and 18% of characters with unnecessary loops, 64% of characters with unnecessary loop and other issues, 12% of characters with unnecessary curves, and 79% of characters with unnecessary curve and other issues. So analysis on related works. There are so many books are available available for recognizing the handwritten Tamil characters, but there is no proper works are available in real time. These are the important works which I collected from various journals and conferences. Here, Mr. Paul Pandian and Mr. Dr. R.M. Suresh, in their research, they have, Mr. Paul Pandian and his team is used curve and conventional features. That is, he used curves, and Dr. R.M. Suresh taken in line and arc as a features. But it's very useful to consider similar shape, that is consider shape, not similar shapes, shapes of character, but cannot address more variation, because only the curves will not help to for recognize the entire character, and only line or arc will not help to recognize the entire character. But this feature will not helpful for recognize the entire that is 247 printed characters. Sorry, the printed characters of 247 Tamil characters. And the researcher Bhattacharya and his teams used to component transition feature vectors, that is a statistical feature, but that is taken out from the zone. Because of the zone and because of the features, he can address more variations, but fail to recognize if character count is increased with more variations. And Premnath is using row-wise and column-wise and diagonal-wise feature variation. And Bhanumati and his team is used to he is taking out the height, width, and number of horizontal and vertical lines, and curves, number of circles and slope lines, image, centroid, and special dot. But it's good to address the characters with the real shape that is printed. Small variation also recognizable, that is small variation found among them all characters also recognizable, but it will not address any similar shape characters and failed if character count is increased. And Indira Gandhi and her team is used height and width as a feature, and Studi is also used height and width. Height and width is highly suitable for printer. Is not enough to address any type of variation. Need a help from other algorithm also. Jagdish Kannan used and Jagdish Kannan sir and his team used endpoints, fork points, holes, length, shapes, curvature, and individual slopes. And Suresh Kumar sir and his team used character height, width, number of horizontal and vertical lines, short, long and short, horizontal and vertical curves, circles, slopes, and image, centroid, and dots. That is also, this feature also used for this feature also helpful for recognize the online characters and printed characters, but it can address in limited samples also. That is, it can address limited samples, means so single character maybe 100 samples or 200 samples. We cannot address more than that. It may be give errors. Fail to address similar shape characters. It cannot address shape variation if character count has been increased. In CAP, ma'am and her team is used vertical projection profile, word profile, background to ink transition is purely statistical features, and Shandini ma'am and his team is used to pixel variation from zone isn't statistical features, and Sudha ma'am used boundaries, that is scale and invariant features, that is also a statistical feature. This is highly suitable for printer and matching with the unit characters. These some of the features already I have tested in my research. So this is highly suitable for printer, and it cannot address all shape and variations. Tamil handwritten recognition system process. Gray image or color image is taken for consideration. So here we are applying some pre-processing steps. That is default pre-processing steps. Binarization. What do you mean binarization? Is binarization converting a color, that is gray image, into a two-tone image, that is a binary image. Osto's algorithm is help for this, and the skeleton Antony algorithm for get the skeletonized image. Normalization techniques used for get a clear image with a good size. And noise removal is helping for get a neat and clear image. Then we are applying a feature pre-extraction step, that is a selection step, we can say it's a selection step. A feature extraction, that is pre-step. Here we are applying junction point based feature selection procedure. You are here I am using chain code, the concept. Here I am using the concept which is taken out from the chain code algorithm. And for feature extraction, we are involved statistical and structural algorithms for get a good feature. In statistical, we are applying quadri and so on. Structural, two different structural formation is happening here. One is direction based, another one is shape based. Is direction, there is 8 directional concepts are applied in structural. In a shape based, strip and prism trees are used. So we are combining all algorithms in the coming slides. For classification, support vector, decision tree, and so many algorithms are used, but the support vector machine is giving a good result. That is a pre-stuff of feature extraction. Here, taking out the character image and scan from the first point of the pixel, and that is scan from the first point of the pixel to get the first mid character with single neighbor. There is a character that is black pixel with a single neighbor. So if I found, then I am applying the chain code algorithm for taking out the feature vector. This is a chain code algorithm that travels to taken out the feature. So it will move to the next valid pixel, and the visited pixels are placed in the same place of another image. That image is taken for feature extraction procedure. The process is come to an end if the black pixel found with 2 neighbor. There is 2 valid black pixel. The pre-extracted features taken for the feature extraction process. Statistically, we are applying some procedures here for extracting the feature. First, we are applying the zoning algorithm. Here we are dividing, there is 4x4 zones. The dividing the subpart of the character image is into 16 zones, 16 equal zones. So, and the pixel density is calculated in each zone, and the average pixel density is also calculated among the entire zone. The pixel which contain in each zone, zones comes above the average pixel density, that part of the zone will be taken for the feature analysis. Next, statistical procedure, quad-tree procedure. Here also there is taking the character image, the subpart of the character image is pre-extracted image on the pre-extracted image. Pre-extracted character image, and the image is divided into 4 subquad. Each subquad further divided, that is 4 quads. Each quad further divided into 4 subquads, and the pixel density is calculated in each subquad. The main quad, which is giving high pixel density, will be act as the main root, that is the main feature for the classification purpose. The rest of the quad, that is subquad, which is giving which is having the pixel value, which is noted in the tree, that is also taken out for the classification purpose. The issues and the successive points and the issues found in from the zone and the quadtree. In successive points is purely statistical base. It can be highly helpful for recognizing the character with the ear shape. Slight changes in shape are also acceptable. Highly fit for unique character, even it has high variation. Similar shape, there is an issue. Quadtree suits better than zone. Solvable if unnecessary loops are introduced by the writer, but support is needed from the direction and the shape issues. It notwithstands if character counts has been increased. Sometimes similar shapes. Not suitable for similar shapes. Cannot accept for a minor changes in real shape. Not suitable for location mismatch, that is shape variation. That is, next one is structural direction. That is 8 direction concepts are used here, and the 8 directions left to right and top, bottom, and also the diagonal. In the 8 directional travel, in the 8 direction level, each level of scan, the direction which giving maximum number of travel will be taken for the feature. For example, if it is having 0, 7 and 6, if it's when you are traveling from the first pixel of the character image, so if it is giving 0 or 7 or 0 or 7 or 6, so but it's not giving other 0, 1 or 2, 1 or something else. If it is giving the 0, 7 or 6, this part alone will be considered as a feature. But the analysis on this directional feature, it can solve the problem of location mismatch. It can recognize the shape if the shape is changing. Give a solution for similar shape, but the issues are giving solution for similar shape but not accurate. Raising issues when character count is increased. The next structural form is a hierarchical tree formation. Is purely for identifying the shape. That is, the character part is taken out. Taken into a rectangle, that is a strip tree. You can apply the strip tree concept in any shape of the character image. The character part has taken into a rectangle, the rectangle, and through the touching point, on the rectangle part, the rectangle formation is divided into two, that will provide two more rectangle that will taken into a tree. So the initial rectangle is taken as a root node. The sub rectangle is taken into this leaf node of the root node R. The same procedure applied in each rectangle to get feature vectors. That is, we are applying the same procedure in each part. The formation is come to an end until no rectangle formation happening in the character part of image. The whole rectangle formation is taken into a tree. Okay, the final tree value is considered the level of tree, and the final tree values are taken into for the classification of us. Is a very good shape representing tree. Here is a prism tree. Here here we are using triangle formation for describing the shape. Here first we have to identify the two endpoints. The two endpoint that is two endpoint thing is the pixel with one neighbor. Finding a two endpoint, note on A and B, and to draw a line and draw adjacent line, that is equal adjacent line towards the character structure from B, that is A and B. I will get a point C. Okay, so you got a triangle here, and continue the steps. That is, here we can, the thing is, it's the C and the adjacent points C and A. That is line C and A on the character structure. We cannot go for the further triangle formation here. So, but here we can form another triangle. We can continue the same procedure on here. Triangle formations. So through these triangle formations, we got a tree structure. With the tree structure, that is, this is a final result of the triangle formation. So from this, we are forming a tree. From the tree, we are extracting the feature. That is, initial triangle is act as a root node. The next level formation here, CA, that is AC, is we cannot form a new triangle from AC, so that is over. Then we can form a new triangle from BC, that is CB, that is extended. The thing is, here the advantage is when the structure is complex, you will get more leaf in the tree. This will give an accurate shape result. It's a very good algorithm for representing the shape. Using this, that is not a quad tree, is prism tree. Sorry. Successive point of this is, but prism tree is better than strip tree. The successive points are location mismatch issues are solvable. It can easily identify the shape of the character portion, give a solution for similar shape. Even minor change also addressable. Shape variation with the location mismatch is not solvable. Not solvable if unnecessary portion has been introduced by writers. For example, it cannot identify the line, because we cannot form a triangle or rectangle from on the line. We'll get only the root node. The final solution is zone. We are implement 5 type of algorithms: zone, code tree, and directional, strip tree, and prism tree. Here, when you are applying zone, pixel density in the zone may not helpful for representing the all character. If samples are increased, it will be failed. It is good for printed character. Quad tree is used for locating the character portion. It is also failing to represent all 247 characters comparing with the zone. It is successful for unique character sets. Directional, useful for perceiving more example, may not suitable for similar image shape. Strip tree is better to represent the shape, but when representing in a tree, it is failed. The main reason is many characters return the same tree representation sometimes. Prism tree, good for representing shape. When comparing strip tree in this application, it is an exceedingly valuable calculation to speak to minor shape variation. Likewise, yet the top of the line variety may prompt disappointment when tests are expanded. But the final is, so we need all type of procedure. So not may not be zone or squad tree or directional or strip tree, but we need a statistical and structural procedure. That is, we need a location, direction, and shape is procedure for classifying the Tamil handwritten character in the further level. This is my references. Thank you.